Attention enthusiasts! Hold onto your seats as the roller coaster ride of Tesla shares takes a dip, while the anticipation peaks for a groundbreaking announcement from General Motors. Brace yourselves for the revelation of their latest innovation, an all-new zero-emission engine poised to render both electric and internal combustion vehicles obsolete. This radical technological leap promises to catalyze a seismic shift in the automotive landscape, propelling us towards a future where eco-friendliness reigns supreme. Without further ado, let's delve into this paradigm-shifting unveiling as the CEO of GM unveils the engine set to redefine our world. What exactly is this all-new technology GM has been searching for? An alternative to EVs. For years now, their search has led them to the all-new compressed air technology. Compressed air has already been seen to be of limited use in the 19th century, mostly with mine locomotives and trams in some European cities, the most notable of which is Paris. However, the technology has since been dropped and forgotten in favor of internal combustion engines because of their immediate potency. However, in the early 2010s, the French car manufacturer Peugeot saw the potential in combining compressed air with internal combustion engines into an all-new hybrid technology that retains the eco-friendliness of a regular hybrid without needing a battery. While these prototypes didn't move far from the testing stage, they did spark a fair bit of interest from the rest of the automotive industry, most notably GM. GM saw the potential that compressed air vehicles harnessed. However, they also realized that such technology needed a fair bit of development if it were to compete with regular internal combustion engines and the rise of EVs. As a result, GM started slowly researching and developing compressed air technology, parallel to developing EVs and internal combustion vehicles. So, with that in mind, it's high time for us to tackle a very practical question, and that is, how do compressed air vehicles function? Compressed air vehicles function very differently from regular engines and EVs. Instead of having a conventional piston-driven engine or an electric motor, compressed air vehicles utilize specially designed pneumatic engines, also known as compressed air engines. These engines are, from a mechanical standpoint, very similar to regular internal combustion engines. The engine uses pistons just like petrol-powered ones do. However, unlike combustion engines, the pistons of a pneumatic motor are connected to a spring. And instead of relying on an explosion that creates the piston motion, pneumatic motors introduce air into the chamber, increasing the pressure inside of it, which pushes the piston to its maximum length. The air is then released, and the spring that the piston is attached to pulls it back into its original position, thus completing the cycle. Generally speaking, the engine is very similar to internal combustion engines and can therefore use a wide array of technical solutions, shortening the development cycle, which is what also drew GM towards this concept. With that in mind, it's time to answer the most intriguing question. What are the benefits of compressed air against EVs and ICE vehicles? Well, the most notable benefit is, of course, the fact that it is 100% pollution-free. It's just pressured-up air, meaning that there is no environmental damage being done while it functions. As a result, compressed air engines solve one of the biggest issues regular combustion engines have, and that is direct pollution of the environment. Compressed air engines also beat out EVs in this regard, as making a compressed air engine is far cheaper and requires no rare earth materials, much unlike batteries or electric motors. Not to mention that powering EVs is also not quite green, as the grid is still mostly reliant on fossil fuels to produce electricity. Speaking of making compressed air engines, another key benefit over internal combustion engines is the cost of production. Since compressed air engines endure considerably lower pressures than gasoline or diesel engines, producing them means that there will be a lesser need for strong and hardened steel or metal. However, as potent as they sound, compressed air engines have a few drawbacks that keep them from being developed and used on a wider scale. Are there any drawbacks to this technology? Unfortunately, there are a few glaring issues that arise from using compressed air engines, which made them quite situational and even borderline useless in the past. The first problem is the fact that compressed air engines are extremely underpowered. Pressurized air has a very low energy density, which considerably lowers its potency. Plus, due to them having light components and them not producing high amounts of pressure, the torque of such engines is extremely lackluster, which makes them much less usable in the real world. The engine also has to spin at quite high RPM, which, considering it's a fully mechanical contraption, leads to excess wearing of components. And if that wasn't enough, since the engine does not utilize liquid as its main propellant, introducing lubricators into the engine isn't as easy as on internal combustion engines. However, the biggest issue that compressed air engines face is the fact that they are extremely inefficient. And while this might sound inessential, seeing how compressed air is virtually free, this couldn't be further from the truth. Most prototype compressed air vehicles that have been developed have a range of only 140 kilometers, which is less than 100 miles. That said, GM has been working extremely hard on ridding this technology of its glaring issues, and they have been quite successful at it.